Hi, next we want to discuss about half subtractor. Half subtractor is a combinational logic circuit. It is used to perform subtraction between two single bit numbers. It contains two inputs and two outputs as shown below in a block diagram. So if you look at this block diagram, here we have two inputs A and B and two outputs D and B, small b, where D equal to difference and small b equal to borrow. Next, how to design half subtractor. Half subtractor is designed in following steps. Step number 1, identify the inputs and outputs of variable. Input variables equal to a comma b and outputs variable capital D and small b, where capital D equal to difference and small b equal to borrow. Step number 2, draw the truth table. In this truth table we have input column and output column. In input column we are having the inputs variable a and b, whereas in output column we have output variables capital D and small b. For two input variables, total 4 combinations are possible: 0 0, 0 1, 1 0 and 1 1. Now next task, we want to generate these outputs values. So here we want to, for getting the entries for these differences for this respective combination, you must have to apply the binary subtraction rules. So according to the binary subtraction rules, 0 minus 0, difference is 0, borrow is 0. 0 minus 1, difference is 1, borrow is 1. 1 minus 0, difference is 1, borrow is 0. 1 minus 1, difference 0, borrow 0. Next step, we want to express each output function in its minimal form. Either students can represent output function in SOP form or POS form. It depends. Max terms are represented by 0, whereas min terms are represented by 1. Here we can also take the help of K-map for getting the minimal expression for each output function. Here we have two output function, difference and borrow. So students will require two K-map for getting the minimal expression for each output function. Here a student can also directly express output function in its minimal form. So by looking at this min terms, I can say that D, here D equal to a bar dot b plus a dot b bar. A bar dot b plus a dot b bar is nothing but a XOR b. So we can directly express D equal to a XOR b. Here look at this column, we have only one min term. Okay, so here we can express small b, means borrow, equal to a bar dot b. For two input variable, no need to take the help of K-map. If you want to apply K-map or if you want to use the K-map, so this is the process. Here draw K-map using the above truth table and determine the simplified Boolean expression. We have two input variable AB, 0 1, 0 1. total number of cells in a K-map equal to total number of input combination. So in this K-map we have 4 cells, which is equal to number of input combination. So for D we have draw the pictorial view of K-map. Then how to decide in which cell we want to put the minterm? So it will be decided based on the combination. So 0 1 combination is having minterm 1. So here 0 1 combination is having the minterm. Next 1 0 combination is also having minterm. 1 0 combination is also having minterm. So here D equal to XOR B. This pattern is also called checkboard configuration pattern. Whenever you find such pattern in K-map, you can directly express your output function in the form of XORing between the inputs. Here for B means borrow, we have only one minterm. Okay, so at 0 1 combination, when A is 0 and B is 1, when A is 0 and B is 1, we have to put the minterm in a respective cell. Okay, so B equal to A bar dot B. Now based on this minimal expression, or based on this SOP form, we want to design the circuit diagram of half adder. So step number 4, draw the logic diagram. The implementation of half subtractor using one XOR gate, one NOT gate for representing A bar, and one AND gate for representing A bar dot B is as shown below. So here D equal to XOR B, D equal to A XOR B, A XOR B, small b equal to A bar dot B. This is A bar dot B. So this is the final logic circuit diagram for half subtractor.